listening to the latest in trance and progressive with Schneider. You're listening to the latest in trance and progressive with Schneider.
Full speed ahead with Monster Tunes.
Hello everyone, welcome to another stream today. Not sure who's here. If you're here, do write in the chat. Be curious to know where you're coming in from, where you're watching from today. Would love to know that. Today's stream we're going to talk about accidents. Or more specifically, we're going to look at accidents in detail. We're not actually going to go to the sites of those accidents because that would take far too long, and the accidents already happened over the past years. But we are going to virtually travel to those places because we have data about those accidents that we can look at. And so that's what we're going to be doing today. The things that I wrote down about things that I'm curious about this type of data is, well, where did these accidents even happen in the first place? Are they happening outside cities? Are they happening in cities? So there's a lot of data we can look at there. There's data we can look at to see if there's any kind of common denominators or common factors. Maybe we can determine some some common traits of accidents using the data set that we have. That's one possibility. Something I also wrote down was maybe there are other data that we can look at about the accidents rather than just the accident data itself to see if there's any underlying causes or correlations. Now, of course, we have to be very careful when we make statements about correlations. There's a very famous expression about causation versus correlation. Neither one implies the other. So just because we find data that's correlated doesn't mean that it's caused by it. And conversely, if we have something that's caused by something else, it doesn't necessarily mean that they correlate, although it can be. But especially correlation does not imply causation. So even if we do find some patterns that mix, or patterns that show us that something coincides with something else in some sort of way, it doesn't mean that it's because of that happened. Simple example, I wake up every morning and I get out of bed, and someone else wakes up every morning and gets out of bed. It's not because I wake up that they also wake up, right? Those things are directly correlated, but there's no causation behind that. So yeah, if you are here, do let me know. Be interested to know where you're dialing in from, as it were. I guess that expression doesn't really work anymore because we don't have dial-up modems, or most of us don't have dial-up modems anymore. Maybe some people still do. I don't know. What kind of data are we working with today? So I've listed them here. There isn't like a video description or something like that I can add to on Twitch like you can on YouTube or something like that, but I'll just leave it up here for the beginning of the stream. And we have three main data sources that I looked at. The first is data about postcodes, PLZ in German, Postleitzahl, and Canton data, so about our different provinces in Switzerland. And the accident data itself comes from the Federal Statistical Office, Bundesamt für Statistik in German, bfs.admin.ch. I also downloaded some weather data. I don't know if we'll be covering that today. It's a little bit messy to work with, and I need to probably spend more time on taking that data apart and figuring out how we can use it properly. So I don't think we're going to be using that data today. But I also downloaded some street data, and this is not to be confused with Street View data from Google, but this is actually data about our roads in Switzerland from the Federal Office of Topography, Swiss Topo. And they all have these great names like Meteo Suisse and Swiss Topo. I don't know if other government arms in other countries also have such cool names. Yeah, and the data about the roads might be helpful in coming up with these sort of common denominators or factors, because I was able to download, like a few different. Basically, I was able to download the entire index of all the streets, and they have some pretty interesting data in it that we can use. So yeah, if you're here, feel free to ask questions anytime. This is like an open stream. If you're not aware of why I stream on Twitch, so my background is in digital analytics, so basically data and analytics. I did not study anything related to this, so I entered it from the side, as it were. And because I was given the opportunity by so many people to learn from them and have great mentors who supported me in my journey in learning about data, I want to give back to the community and give back especially to people who are coming into this field or who are already working in this field with less years of experience than I have, and are looking to have questions answered or are really curious about certain topics. And I want to provide a way for those people to learn interactively. I already coach 1 or 2 people on a sort of semi-regular basis in certain topics around data and analytics, but I really thought that Twitch is a great platform for real-time interaction. Ultimately, it's a really special way to basically have the chance to answer things in real time, even if the answers aren't always as simple in our area. But we will be covering lots of different things. I mean, at the moment I'm just covering sort of some data analysis things, but in my next streams I will be looking at doing more about maybe data collection, or also some topics about auditing data collection on a website, like seeing what's being collected, where, in what way. So that's what I'm interested in doing. I'm just going to forward this. This is the intro, which is a bit annoying. There we go. So do let me know if the music is too loud or too quiet. I can adjust the volume here. I can also change tracks. I can play some other genres as well, if you're interested. Yeah, that's it. I think let's get started. So, what have I done so far? I've been doing some work in advance, but I'm gonna walk you through it. The query is very small at the moment. It's not that interesting. What have I done? So I've imported these different data sets. The first one from the Federal Office of Statistics is this PLZ Canton. So if we just want to take a look at that. I'm apologizing in advance for the German, so there's nothing really I can do about that. A lot of the data that I got is in German. I mean, even the data set itself will be obviously in German in some cases, but the actual column names and things like that are in German, but I don't think it detracts from what we're trying to do here. If you are curious about what type of database I'm using or something, this is Postgres. I'm running it within a Dockerized container so that I can just shut it down and then boot it up again with all my volumes attached, and I don't need to leave the data sort of installed in my machine, kind of like I don't need to install Postgres. I can actually just run Docker. It also means I can run other things, which in the last streams we actually looked at. We actually used Metabase, which is a sort of BI reporting engine to visualize some of the data that we were looking at. So I think that's pretty cool. But yeah, just so you know that I'm using Docker. Christy, nice to see you here. Did you wander over from Ekaterina's stream then? Nice to have you here. So what are we looking at here? So this is the first table we're looking at is this postcode canton table. And we needed this because we're gonna try and look for different patterns, and one of those patterns could be cantons. And so we do have the cantons name here, Cantons Kürzel it's called in German. Yes, this is data grip that I'm using. It's a custom theme. It's a material theme called Material Pale Night. I am a huge fan of data grip. I think it's one of the easiest tools to work with data when it's in database format, at least. But you can also import CSV files and work with them, which is very useful. Huge fan of JetBrains. Yes, I think they make great products. Have to say their subscription method is a little bit expensive for private people, like if you're just buying it for yourself. But yeah, there's a lot of ways to get discounts and things like that as well. So coming back to this table, yeah, when we're looking at different road accidents, we are really curious about if there's some common traits about, okay, do accidents occur in certain cantons, for example? And then we have to obviously have a table of all the cantons in Switzerland. And I went a little bit further than that because I downloaded a table of all the cantons in Switzerland, but also with all the postcodes. And this is something that I'm probably going to need at some other point in time. So I downloaded it. What's interesting is that there is a easting northing location data within this table. And I'll get into the location data stuff later, but for now, this was something that was really complicated to think about and really complicated to work with, because I was more familiar with lat-lon, so latitude, longitude, and not with easting northing. But it turns out that every country kind of has different ways of denoting this type of data. And I realized this window here is actually blocking the top part of the table, so we're just gonna plop that over there. I think that's a bit better. Or maybe we don't need it at all. We could just take it out for the moment. So yeah, if you have any questions, Christy, just feel free to ask in chat as well. So basically, as I was saying, some of the columns have not great language because it's in German, so it's not great for an international audience. But yeah, let's move on to the next table. So these 4 tables here on the left, these are the 4 accident tables that I was able to get access to. The first one is the type of accident that occurred. So it's in German again. Sorry, I'm going to translate those values when we start working with the data. But basically the type of accident, so like the severity of the accident, which canton it occurred in. You see that we have the canton here. What type of road, so like highway, next to the highway, and the location. However, the location is only divided into 2 categories, and that's innerorts, außerorts, which basically translates to within a sort of 50 kilometer per hour zone or outside the 50 kilometer per hour zone. And then we have all the years. So we have 92 up to 2019, which is pretty cool. So we do have 17 years worth of accidents based on these criteria. So that's the first table that we have. Then we have another table, and the reason these are in separate tables, just so that you understand, I couldn't actually download the data in one data set. I actually had to use the Federal Office for Statistics tool called stat tab to actually create these cubes. And some of these cubes are pre-created for you, and I'm not able to get all of the different data for all the different things into one data set. Chrissy says, it seems not normalized, like road type as a string and not as foreign key. This is the way that I've imported it. So the way that I've done this is, in this table here, you can see I've just imported these as text. I'm not so concerned with having these primary and foreign keys, especially because these tables are really descriptive. So like the Canton, for example, is not a key in this table, because each row is distinct, so there are different properties for each row, but I don't want to have a key necessarily in this table. I could make an ID or something like that. And I'm not so concerned with foreign keys because I can just figure out what to join them on later. But yes, it's a good question as well, that if I was working with data for a longer period of time, I don't know how long I'll keep this data set in here. Maybe just for today or maybe for the next stream. But I would, I would probably get rid of it. And if I was going to re-import it, I might do it better next time. And there's a lot of like formatting issues with this data set as well. But that's not so much of an issue because I want to translate these values anyway. I actually want to change them from the German values anyway. I want to change them to readable English values, and in some cases just translate them to number or something like that. So this second table we have is about causes, and you'll notice if you read German or if you're observant that we don't have the Canton, so the province. We don't have that data in this data set, in this table. So it will not be possible for us to actually work out, for example, if I have this table about the Cantons and I have, okay, these are all the deaths, the road deaths or road accidents that I had in Zurich on the highway, which is outside a major city or outside a city. I can't just join this data set onto it. Even though I do have this this key here, these two properties, I don't have the drill down by canton. And I actually requested this data set from the Federal Office of Statistics, but they haven't gotten back to me yet. I assume because it's, you know, the end of the year and they're probably all on holiday, rather than checking if they are collecting their data or checking requests for data, let's say. So that's a little bit unfortunate. I would like to have basically all the data by canton. So I would love to have the canton in this table as well, in addition to these dimensions, but they did not provide that in the tool that they provide. Another table that we have, which also doesn't have the canton in it, so we won't be able to do data, for example, of the accidents by canton, but we do have information here about what type of people were involved in the accident. So how old they are, men and women, what role they were in when they had the accident, and what vehicle they were using. So for example, let me show you here what one row means, just so we can understand this a bit better. This one makes no sense. So this one is actually very logical. So in 1992 there were 5 deaths where someone was a pedestrian, so they were not using a vehicle. They were a pedestrian in the accident. It was men between the ages of 30 and 39, and they were not using any kind of protection system. So it could be like a helmet or a seatbelt or something like that. And this table will just allow us to sort of summarize what types of accidents occur to what types of people. And it will be interesting because in the causes table, we do have this Objektart or Verkehrsteilnahme. Basically means like what vehicle was in use during the accident. And we actually have sort of this this column here. I will need to see if we can actually join it and actually drill out the numbers, whether it makes sense. but that's something we could potentially look at. The fourth table we have is data about the roads, and this is actually quite interesting. I personally didn't know that they are collecting the data about what the condition of the road was in terms of weather, which is why I went and actually downloaded some weather data from the Federal Office of Meteorology. But if I had known that actually the weather conditions are in this data set, I might not have done that. Or I might have done it anyway, who knows. But it is interesting that the road conditions here are also part of the roads data set, where they say, okay, this is, for example, the severity of the accident, the type of road itself, so this is a highway. Again, this distinction of being within like a city zone or outside a city zone, the speed limit at the time, so this is up to 20 kilometers per hour, and this Vortrittsregelung, I guess the best translation for that would be who has right of way, or whether there is kind of a right of way distinction. And in this particular case, on the highway there's none, so it was probably just a normal section of highway. Up to 20 kilometers per hour, there were no accidents. We can see that. The reason for that, and the road condition was dry. The reason that there's no accidents in this scenario is because there are no highways where the speed limit is 20. The lowest speed I believe that the highway can go to is 60 in a construction zone, possibly 40. Sorry, I just need to drink some water here. I'm still not used to the constantly talking for 2 hours thing. As I said before, if you do have questions or something you want to know or remarks, feel free to write in the chat. I like to interact with people while I'm doing this kind of work. And so I'm very curious about whether we're going to be able to find some common traits here about certain accidents, maybe at certain speeds, that above a certain speed and in certain conditions like snow covered, that certain accidents occur. So that's already, for me, quite interesting, because I would like to know more about accidents in Switzerland. I realized that the title I published this stream under, so let's find out more about car accidents with SQL, could be a little bit misleading, because I don't actually mean car accidents with SQL. I mean car accidents that occurred and we can find out more about them with SQL. But of course it could be read as, oh, people had car accidents while using SQL. I think, I only realized that afterwards when I was reading it again. But yeah, you should definitely not write SQL while driving or operating any kind of vehicle, or use your phone at all for that matter. I think that would be best for everyone. So I'm just going to close out these tables here. It's a little habit I have. I have been preparing something in the background, but that's maybe for later. Let's continue with the overview here of what data we're actually looking at. So weather data. Christy, did you find my joke funny? It's a little bit nerdy, I'll have to admit. So I downloaded weather data. I'm going to just sort of gloss over this part because I don't think we're going to be using the weather data today. But there are these weather stations. Oh, I actually just noticed that this is not so clean. So I'm just going to give me a second here to delete these out. There we go. So I just deleted those rows out of that table. So we have these 29 weather stations in Switzerland, which is actually not that many, but these are the sort of primary stations for the measurements. There's data going back like 200 years almost, which is pretty impressive in some of these stations, and they have, you know, all the station heights, the coordinates, including lat long. We also have this climate region. This data is in English because Météo Suisse is actually publishing this in English, which I appreciate. And there's the canton. And I basically was interested in sort of mapping the weather data to the cantons itself to determine whether weather patterns within each canton might affect how accidents occur. There's most certainly a correlation. Whether it's the reason for things is another question altogether. But I did download all the measurements that are available on a daily basis since, well, 1864 in this case. So it is quite a large table. This table is 1.3 million rows, but as you can see, the performance in my local Docker container with DataGrip here is fantastic. I mean, that count took almost no time at all. 39 milliseconds here. If we look in the log here, I'll just make that a bit bigger. We can see that actually took 39 milliseconds. So this is a really nice way to analyze also large sets of data without relying on a cloud infrastructure, paying for storage, for example, in BigQuery or whatnot. So yeah, Christy, wow, quite impressive. Yeah, I mean, I maxed out a few weeks back. I was trying something with something like 55 million rows, and then my computer really started sweating. So I run a quite high spec MacBook Pro 2019, 16-inch, but yeah, it really started sweating, and it was really having difficulty processing. And I think the bottleneck is actually between Docker and Postgres itself, and DataGrip itself. DataGrip itself doesn't have a memory issue. They can definitely handle way more than that. But yeah, that sort of bottleneck, Docker is only able to feed so much through your kind of local connection, because it stores a lot in memory as well. So yeah, I think working with cloud architecture for like very large data sets is convenient, but again, you have those costs associated with it. So the measurements are actually pretty interesting. I would have to look up more about these particular columns. I didn't write it down for the moment about what they each mean. Just make this a little bit bigger here, like these prefixes, pre-stat 0 and stuff like that. I think if we went where, I don't know, let's say date, let's go to a date that we can familiarize ourselves with, like 2010, 10, for example. So in one of the stations, like Neuchâtel, we had something recorded 10th of October, so 31 something, not sure what that would be. These are probably temperature readings, like 10th of October, that seems like it could be temperature readings for that day. 80.8 is maybe barometric pressure or something like that. I'd have to go look up the columns, what they mean. But it is very interesting, and I think there's a whole lot of things you could do with weather data itself, because you obviously have this day. So if you have data by day, then you can take any other data set by day and sort of just put them over each other and see, okay, I don't know, does weather affect sales in stores and things like that? So there's a lot of potential there. Just gonna take another sip of water here. Hydrating is important. Also for my throat, so that I don't go all hoarse on you guys while explaining this stuff. So yeah, that's the measurements data set. So that's interesting, but maybe we won't be using that today, who knows. And so then there's the street data set, so about all the roads in Switzerland. So I was quite surprised. This is 200,000 rows. I really thought there would be more roads in Switzerland. And it turns out that I was right, that there are more roads. They're just not kind of officially indexed. And that's a bit weird in a way, but I guess it's because it's purely not feasible to just all these tiny little, I don't know, like all these tiny little roads that sort of just have one or two houses on them that aren't really classified as a road or something like that. So this data set's pretty interesting. There's a label for the road. Each road has its own ID. So Chrissy, coming back to your question about, primary keys, foreign keys, I could have imported this stresid as a primary key, and then in this other table here I could have used it as a foreign key, but I just chose not to do that for simplicity. But most definitely you could do that. Yeah, it would make sense to do that if you were going to really want to store the data set properly. So yeah, we have the label of what these streets are called. Don't ask me to pronounce all of them. I can pronounce most of them, but some of them I'm really uncertain about how to pronounce them. And my German is fine. Like I speak German fluently, but this is just, I don't understand these. Also the place name, so this is like the postcode and then the place. And they've actually taken out this, I actually don't know like what this number is. I tried to look it up. I have to maybe consult the original, the source to figure out what this FOS number is. But they have the community, and I assume that this is maybe like a community number or something like that. There's the Canton. If you were here a few minutes ago, you may have seen this data set here, where we also have the Canton in it. So this is very cool. We could technically link these together and figure out how many roads are in each canton, because that's something I also thought, like maybe the number of roads determines how many accidents there are. I don't know. Or it's like, a sort of incidence rate. This canton here is written out, and in Switzerland we also use this kind of short form. This is actually what's on our license plates, this two-letter format. So we'll definitely need to make a sort of lookup table between the two. And if you saw beforehand, that's kind of what I was doing before, just to save us a little bit of time during the stream, because I think that stuff's kind of boring. You let me know if you don't think that's so boring, but yeah. What else do we have in here? So let's keep looking at this weird named street. So there's these like street types. I didn't look into so much detail yet about what kind of different street types there are. Also some like official and status and valid columns. I assume that your street needs to be real to be significant or something like that. It's also quite interesting. Modified dates, which I assume is just from the data set. And then we had this here, easting and northing. And I'll already take this away like from you having to go look at this and figure out what it is. Basically, they are distance criteria, so kind of like lat lon, and I didn't really know so much about this. I had to do a lot of research about this. Christy says, nice data set and nice task to reverse engineering it and aggregate statistics that you want. Yeah, it is. This is why I'm really curious about this data set, and there are a lot of things you can find about accidents in Switzerland, but I kind of wanted to just do it myself, and I thought that's a great opportunity to show something on stream as well. So, like I said, I have to find things that I can show on stream that aren't confidential, so that does limit my choices sometimes. So yeah, about this easting and northing, I actually didn't know so much about these, sort of location and geospatial data. There are people who are really specialists in that. And basically, I had to figure out how to convert these into lat lon if I wanted to use them together with something like measurements of these stations. For example, this station here, this Altdorf, or wherever it is, if I wanted to figure out how to use that, I have a station metadata, so Altdorf, and I actually have easting and northing in here, but I also have lat lon, and working out sort of distance between lat lon or distance between easting and northing is more difficult. So lat lon is kind of like a standardized approach. Yeah, I think there are other street types in street. We're definitely going to look at that because I'm interested to see what other street types there are. Maybe there's like, I don't know, like a path or something like that as well. But basically, I wanted to convert the street index. Sorry, I just got lost here. I wanted to convert these streets to not only have them in easting and northing, but also in lat lon. So I actually booted up a different version of Postgres, and you can maybe see that here. If I actually just show you like these standard tables that I have here, spatial ref system, I actually booted up a Docker container of PostGIS, and it's not it's not the other PostGIS that you're thinking about. It's actually PostGIS, which is a geospatial plugin for Postgres. And there's a Docker container for it, and it allows you to basically use spatial equations to work out distances. And that's something I'm probably going to be doing in a future stream when I've read a little bit more about it and about the different things you have to be careful about when you're calculating that stuff. And there's definitely a lot of math involved. I can give you a little sneak peek about what kind of stuff you can do. You can sort of, like work out distances between 2 points. So I was doing that here. Work out the distance between 2 roads. So the distance here is like 3,812 meters between these 2 points. And it gets very complicated very quickly, and I need to spend a lot more time figuring out the basics before I would go over it in a stream, to make it as useful as possible, that I wouldn't just stream for like 7 hours of me trying to figure out stuff, because I don't think that's very exciting, to be honest. So that's something probably for a later stream next year, seeing as we are almost through this year. Although, to be fair, I don't think 3 days is going to change too much at this point. Christy, wow, nice, I will come see it, certainly. I'm very happy to have you join for that stream as well in the future. I would love that. So, easting, northing, I converted them. I found a conversion tool that actually the government provides. It's very nice of them. The name of the tool was something odd. Let me just call that here in my notes. It was called Reframe. I have the link to it if you would like to see that as well. Basically changes northing easting from this Swiss standard, which is LV95. It's like a proprietary standard for Switzerland, which basically sets a midpoint in Bern, which is our capital city. Not Zurich, in case you were wondering. And then it calculates the distance from Bern, and or they've used that distance. And so what I did is I submitted basically the street index to that tool, the whole table truncated. I just put in the street ID easting, northing, and it spits back the street ID latitude, longitude. And that's honestly, that's pretty cool. I'm quite like that. So, yeah, I converted it. I was quite happy about that. And that's all there is to say about that data set for now. Maybe we'll need latlon, maybe we won't, maybe we'll need it later. It doesn't really matter. It didn't take me so long to figure that out. I'm happy that I did it. It is correct. I actually put in the latlon to compare it to the easting northing data in Google Maps to see if it comes up with the same point, and it does. So that's nice. Let's get to the fun stuff. The first thing we need to figure out is what's our first question? Like, what's the first thing we're going towards? And the first thing we're going towards is, I think, kind of summarizing the accidents. So we have this data set here, which is basically the number of accidents, or rather the accidents with deaths, accidents without deaths. There's all these kind of different categories. There's 936 rows in this table, which is not that much. So performance is very good, obviously, 3 milliseconds. And I think it would just make sense to have an idea about how many accidents happen in each canton per year. just to sort of have a baseline. And I like to do this when I'm working with a data set, before I go really, really deep into figuring out incidence rates or something like that. I just want to kind of summarize stuff first. And I usually make some notes on the side as well, and I say, okay, this is what I found out so far, just to sort of keep track of things. And it helps also when explaining this to someone later. In the case of a stream, okay, they can go watch the recording for 7 days at least. But it helps when explaining this to someone who didn't do the whole analysis with you. I think it's really easy to then take them through the steps and say, okay, yeah, I looked first at the sort of overall aggregates and this is what I found. So looking at this data set, I'm just going to start a new query. New query, new day, new query. Let me know if you like this color theme. I've been playing around with a few different ones. I landed on this material pale night, which I'm quite a fan of so far. And I do think it's good also for the eyes, obviously. Doing a lot of stuff now in the dark because it's dark out early, so I think it's important to protect your eyes, and dark mode helps a little bit with that. So, first thing I do with my select statement, just want to get my table in here, and then I want to work out what to call this table. I think I'm going to call it RAC, R-A-C. So here's my table. Let me know if you can not read that too easily. We're obviously going to be working with a smaller subset of the table. So Chrissy says your theme is fine. Wonderful. If anyone else has suggestions for other themes as well, happy to hear it. So what do we want to select here? We have to be a little bit careful with this data set. Let's look at one canton at a time. And actually the easiest way to do that is just to select, for example, Zurich. And I'm just going to select one canton, and I can see that there's 36 rows here. And the reason there's 36 rows is because it's basically a breakout. And we have, for this one canton, we have 3 categories of severity. So we have light injuries, heavy injuries, and deaths. Then we have the different street types, or the road types, and the categorization of the location, where there's 2 types, basically inner city and outer city. Now, if I start to classify these a little bit, let's do that, because I actually don't think they're so legible. So we're gonna call this Unfallort. So I want to take this location of inner and outer city. So when Unfallort is Außerorts, then outer city. I'm going to make a second condition when Unfallort is the other one, Innerorts, then inner city. Now, I could easily just use an else, because I know there's only 2 values, but I'm doing this in a sort of clean way and saying, okay, give me these 2 values, and I'm going to put the else in here, else unknown. And I do that basically because otherwise it's null, and I don't want nulls in the table after I've started working with it. Let's make this pretty. And then we end. We end with, what should we call this? I don't know, location type. It's an odd descriptor, actually. It's a bit difficult to summarize. So if we just do that, then we can see we have all these different values, 36 of them. But if we slap this distinct in front, distinct basically means just give me as many rows as are uniquely different from each other. And of course, there's only 2 values. So this is one way to also figure out what types of values you have in your table. So, Christy, going back to your question, we're just going to jump from this to the other thing about the streets. I'm actually kind of curious about that street thing. So we're actually going to just jump to the Swiss Topo Street Index. I'm going to call that the table of sin. And we're going to go to sin dot, I think it was, what was it called? Street dot type. I can actually just check. Yeah, street dot type. So if I actually type this here. Oh, so there's actually in this street data set, to answer our previous question that we wanted to know what other street types there were, there's actually areas and places, which is kind of interesting. I didn't know there would be that. So I just actually am curious. str.type sin.type equals area. Oops, we have to be careful with spelling here. Let's have a look at what those actually look like. Interesting. So these are not streets, but like areas within communes. So the kind of geospatial structure of Switzerland, just to also have that covered, is basically Switzerland, so the country, then, and not Sweden. People still do that, unfortunately. So Switzerland, then we have Canton, and there's 26 of them. Within each canton, there's then municipality. Oh, I can never spell this. I don't know how many there are. Let's just put N. Austria and Australia. Absolutely, Christy. Austria, Australia, I hear that one all the time as well, because I have a colleague who works in Austria, so. Yeah, so there's 26 cantons, then there's N municipalities within those cantons, and within each municipality, there's also communes, which is kind of groupings of houses. And then there's basically, I don't know, there's some kind of hamlet thing. I'm not sure if it's really official or not. But basically this STN label is kind of a hamlet, if I'm understanding that correctly. I mean, it is official and valid and real, according to this data set. But yeah, that's a little exodus into the street data. So that's not so important for now. But basically, I want to figure out from this original table, this road accidents table, I just want to start summarizing per canton how many accidents there are per this category, for example. And I need to be a little bit careful. If I do sum of 1992, so this is sum 1992, I can't start my column name with a number. That's just a no-go. So I have to start it with something else, and I like to use the denominator, so the aggregate function that I used, I like to use that in the name of the column, the alias. Oh yeah, sorry, I haven't been writing as for the alias. That's just something that I don't do, but it is cleaner if you want to read it if you haven't been writing the code. So do remind me to actually write the aliases down, in case I don't do it. Anyway, so we filtered blah blah blah. There's something missing here, and that's the group by. I always forget to do this, so I'm actually pretty proud that I remembered. The group by just means this is a dimension and this is a metric. So I have to find out how to group this metric by something. And if I don't do that, it doesn't know how to calculate. That's why it gives me this red error bar, which basically makes my eyes bleed. So now I have a sum of the accidents. And this is quite interesting. We need to actually double check whether this is correct. So we have 2302 plus 800, which is pretty easy to do, but I'm checking it anyway in my calculator. So that's 3102, and this is for Zurich. So I should have a total of 3102 accidents for 1992 for Zurich. How can we check this? Well, I can sort by canton, and then I could just copy this, for example, into like a Google Sheet. I don't know. I'm doing this off screen, but I could just copy this into like a spreadsheet and then figure out if that's the right sum. And it is 3102, by the way, which is nice. That's one way of doing it. I could also just take out this case when. And this is where a nice little function comes in handy, which is if you press the Option key, at least on Mac, you can actually comment out multiple lines at the same time. So you actually hold the Option key and then drag your mouse. And then I can take this group by out. And if I run this again, I actually get the sum. And I can check it. And it's the same. So that's cool. And if I were to now include the canton instead, so I could just say distinct canton, we're going to call this canton, the English version. Put the group by back and comment out this. I already have, oh, let's order it. That's ugly. I already have the accidents per canton. Not bad, right? It's pretty cool. However, this is just the raw number, right? It's not that interesting. So that's already something. We can already see which cantons have a lot of accidents. And I'll tell you already, if you're not familiar with Switzerland, Bern, Vaud and Zurich are also some of the largest cantons that have a lot of traffic nodes and a lot of roads and a lot of cars going through them. So obviously a lot of accidents will occur there. It's a sort of implied thing. But yeah, we want to go a little bit deeper than that. But like I said, it's just nice to already figure out some basic stuff in the beginning. And one of the basic things I would like to look at is the percentage distribution. So I can see the raw numbers here, but I don't know how many percent these account for. There's a couple of different ways of doing this. There's the lazy way, and then there's the right way. Obviously, we need to get a sum of each year first in total, and then divide each canton's row by that sum. And so one way of doing that is basically saying, okay, if I do like this, sum 1992 divided by, let's say the total was 30,000. I need to make one of these a float so that I get a percentage, or so I get a decimal, sorry. And if I do this, it's not, so Christy says, is it like a weighted average? No, this isn't a weighted average because I'm not considering each row to be different importance. I'm actually just using a fixed number in this case. I'm just actually working out a percentage of all the accidents. So if the total was 30,000, then Fribourg would have had 2% of all accidents. So there's a couple ways of doing this. Instead of writing this fixed number in, we could actually have the real number. We could work it out by taking out the canton and taking out the group by, and then just running the query without this, sorry. And then we actually, oh, I wasn't far off, look at that. I'm actually shocked. I was not far off at all. Okay, that's cool. So we have the total, which is 23,272. And I'll promise you, I wasn't cheating. I actually didn't look before what the total was. So it was just a rough guess by my brain's subconscious part, having seen all those numbers. Sorry, just another hydration check for me. So we actually have the total. So we could just do it this way. 23,272. Put in the Canton again. Put in the group by. And then we have, we need the float, sorry about that. See, if I don't change this number to a float, or one of them to a float, intuitive guess, yeah, I guess it was a bit intuitive. Although it's a bit strange that I know roughly how many accidents there were in 1992, when I was less than 10 years old, and didn't know that I wanted to do data analytics stuff. That's kind of a funny thing. But you see here, so Argao had 6.6% of accidents, Baseland had 2 point something, etc. Bern, 13%. What are the big ones? Zurich was also a big one, 13%. Vaud, 11%. Yeah, so this is one way of doing it. Is it the best way? Not really. I don't think it's so nice to do it that way. The other way to do it is to first make a summary table and then divide by total. Because let's not forget, we actually need to do this for every year, because this table has 17 years in it. So the smart way to do this for this entire data set is to create a roll-up table first. So we're going to create that using a common table expression. Common table expression, CTE, just means using this with clause. So with, let's call this yearly summary as, and I basically make this sort of alias. And what that does is it allows me to group different types of data or different perspectives of the same data set into the same query and execute it at the same time. It also makes the query more efficient. So what I want to do with the yearly summary is nothing else than actually we've written here. I can actually just plop that in here. I'm gonna have my auto formatter tell me how this looks good. I don't need this case when for now. So I have Canton, which is Canton. Again, I didn't put this in. You guys gotta warn me if I don't do it, because I think it makes it more legible. But if I don't do it and it doesn't bother you too much, then that's also fine, I guess. I have basically a summary table. And so instead of dividing this, I'm going to do sum 1992, and I'm going to call this sum 1992. Now, of course, I do need to do this for every single column, but I can copy. So that's nice. And I can do better than copying. I'll show you some cool trick as well with that option key. So I can also highlight multiple rows at once, multiple columns, and I can multi-change, but unfortunately I can't change them kind of at the same time. I wish I could do that, sort of type a different number in each of them, like sequentially, but that doesn't work. So we are going to have to type this out manually. Just trying to entertain you as we go, I guess. So everyone who's here, let me know where you're watching from. Curious to know if there's anyone from Switzerland here, because we're looking at Swiss accident data. I don't know how much of this information would apply to other countries. Something interesting to maybe look at some other day if I can get some accident data from other countries so we can compare. So Christy, I am from Russia. By the way, is it possible to calculate population versus accidents correlation with population by year if only one exists? Yes, most definitely. I mean, we can make a kind of incidence rate, so accidents per population. I actually wanted to add population data in here, and while I was setting things up, I actually downloaded it, but I didn't import it for today. So yeah, something we could import some other time as well. Also, yeah, definitely something to look at. I'm going to add that to the list for next time, is maybe to look at the population stuff, because I do think the incidence of accidents per population is interesting. What's kind of tricky is there's a lot of mobility involved with accidents. So someone who has an accident in Zurich doesn't necessarily come from Zurich. So like doing the incidence of the population of Zurich is a bit tricky. But yeah, this, of course, it's quite interesting to look at that. I think it's something worth doing. Yeah. So we have up until 1999. Now we need to do the 2000s. So actually the data set is 1992 up until 2019. So I actually did wrong math before. We have way more than just 17. So this is a bit tedious. That's for sure. But yeah, maybe we could just do it for the last 2 or 3 years, just for completionist reasons. I could do it later for the other years as well. But yeah, it would make sense to look at the whole data set. That's something like, obviously if we want to find patterns, then we need to look at a longer time period as well, because it enables us to see kind of larger patterns that are occurring. So Chrissy's from Russia. Is anyone else here from Russia, or am I just attracting people from Russia at the moment? We have worse accident statistics here in Russia. The culture of driving is bad. I actually watched a GIF this morning of some guys putting up a construction sign on the road in Russia, and people repeatedly driving into it over the course of several days. And they kept putting it back, and then people kept driving into it, and I was actually quite surprised. I didn't realize it was that bad. Where do you think, Christy, where do you think that comes from? Why do you think that is? Do you think there's like a reason for that? Is it just culture, or is it like bad driving education? You know, there may be like different reasons for that. So sorry, I'm just going to plow through this. Probably should have done something like this beforehand as well. But I didn't realize that we were going to do this today. That's the beauty of data analytics. You sometimes don't know where it's going to go. 15, 16, 17, 18. So we need one more for 2019. Obviously 2020 is not here yet. I assume that it would be a statistical outlier in terms of accidents, because the number of vehicles on the road dropped significantly during lockdown that we had here in Switzerland. Probably like, yeah, over the sort of March to May, end of May period. We're always falling behind Europe by 50, 60 years. It's our national characteristic, like a challenge. That's quite a quite a sadistic view of that. Always running behind. That's unfortunate, definitely. But well, everything is different in each country, right? Switzerland also has its problems. So what do we have here? This query is giving us the sum of the accidents in each canton. Do we need the canton here? No. The reason we don't need it is because we just want an aggregate table of the yearly summaries. And so we don't need the group by either. And now we have this beautiful table. There we go. So we now have 92, 93, 94, 95, etc. And they're separate columns, which is fine. That's not an issue for us. Now we have to figure out, how do we divide this? Well, this is a little bit easier. So we have the Canton, and then we have this sum of 1992. We don't need to do that anymore because we already have it up here. The question is, how do we use this? Well, first we have to select this yearly summary. So instead of doing from the road accidents table, we actually just do from yearly summary. And so we actually don't need to rewrite this anymore because we have how do you say? Yeah, we already have an alias in this table. And if I hover over it, you can actually, in the hover, you can see what's defined. The problem is, we don't have this Canton, so you just put this back. We don't have this in this data set, right? We just did sort of the summaries. So what we actually have to do is find a way to join the tables or bring in that data in some other way. How do we do that? Well, we can basically just say from, so I'm just going to undo this, from road accidents, and then we're going to union. Actually, should we use union here? Maybe we can just join it. Might be easier. So join yearly summary. Do we have the data by Canton? We don't. We just have the totals. So let me think about how the best way to join that. I think the best way, because if we do a join, then we have to have a key. And of course, the sum of 1992 is not equal to 1992, right? It's not the same key, right? So we would have to actually create, oh, you know what? We actually have to do this in 2 steps. We have to create the yearly summary by Canton first, and then let's do this, Canton. So we have to create the yearly summary by Canton first, then in a second query, so in a second common table expression, we have to actually do a yearly summary. And here we can select star from yearly summary Canton. And what we can do now is we can actually just get rid of the Canton itself. Right, and that should work. So we have yearly summary Canton, and we just take the, let me think, yearly summary Canton. We just want to have sum of 1992. We want to have everything except the Canton. So I think we can use the except clause. Except Canton. I think it works like this. Let's see how that works. All right. The problem with testing common table expressions is you run into the issue that this is not working with the except. You run into the issue with common table expressions that if you want to run them separately, you always need to have the right syntax, like you have a comma in between each one and things like that. So they get a bit tedious when you're sort of QAing your query. I was trying to avoid that, but I will just copy this. This is the nice thing about that option key. So I'm actually copy all these column names from this one into here, so I don't need to retype them. So these are the sums. Yeah, it doesn't know that this one exists, but it does. Yearly summary Canton does not exist. Well, it does. And the common table expressions are sequential. So we have to be careful that we don't try and use something that didn't exist yet, because it runs them that way. At least that's how I was taught. It may be different. Just gonna hydrate. All right. So now we have two tables again. We have a yearly summary Canton. We have the yearly summary, which has just the numbers by year. Now if we want to create this sum, then we have the Canton numbers, which has, so from yearly summary Canton, which is YSC, so we have the Canton itself, and then we have the sum of 1992, and again we actually run into the same issue. I actually hadn't thought this one through yet. So we run into the same issue because we don't have this key of the sums of the total. Unless we have a total of everything, we won't be able to do it properly. Yeah. So it's not possible to join without a key, but it would be possible to probably join tables without key. As long as we have the same number of columns, we can use union. Or cross join. We could try just cross joining. So if we just cross join yearly summary, Christy says, does it mean you need to transpose columns to rows? I should not need to, no, but we can find out if we need to do that very shortly by running this. A little bit afraid. Let's see what we get. Let's just do, for the moment, let's just leave this how it is. Yeah, I still need to group by. Or why is it, sorry, no, we've already grouped earlier. We don't need to do that. Blah blah blah. Okay. Let's try and include now the why is this not working? Some weird formatting stuff going on. Okay. Let's see what happens when I include this entire table. So yeah, no, that's good. That's what we wanted. So basically what's happened is Argao has 1547 is the total for oh, that's interesting. YSU sum 1992 is 32, but that can't be less than the sum, the total sum. It's odd. Just trying to work through this, but what logic was used here? Let me just see if I just execute this yearly summary. Oh, I see, because because I actually used it from the yearly summary Canton. And if I just look at the yearly summary, yeah, that's not cool. Those are not aggregated. That's the issue happening here. That's the issue. So we don't need the yearly summary by Canton, because we can do that on our own. We definitely don't need to transpose columns to rows, because it's the right thing that we want. We want the value, we want those metrics to be in columns, but we actually don't need this yearly summary. This yearly summary Canton rather. So we're just going to get rid of that and just use yearly summary. And we're going to do, instead of taking it from here, we're actually going to take it from the data set. So this road accidents Canton, rack, and basically sum of 1992 is the sum of 1992. I'm just going to comment these out just to check my work before I continue. And I can just execute this query here. Why is that wrong? Oh yeah, that's the problem with trailing commas. Yeah, so now we have that 23,272. And so basically I want to do this repeatedly. So we're gonna have to do some magic. Some, at least we can do with option, we can write these a little bit easier. I go like this and copy, and then I move over. Conveniently, all years are 4-digit. I can just do it that way. And now I will have the sum for each year. Forgetting my comma again. So the sum for each year, voila. Again, that's what we wanted. And now we can get rid of this. Select distinct. So we have to use the FOS road accidents Canton table, rack. So we need to use Canton, which is Canton. And now what we do is we say, so the sum of 1992, right? Let me just comment this out so we can go through this together so it makes sense. Basically, the rack of 1992 is the sum of 1992 for that canton. So let's maybe write CN in front of that. Or so let's say sum CN for canton 1992. So when I execute this, it gives me the sum of each one. This makes sense, right? Now, you can see here, it's giving me multiple values for each canton. Why is that? That is because we didn't use a sum function. Voila. I don't even need to put these in double quotes. Yeah. So when we run this, we should now get one row, if we don't forget to use our group by, of course. We will get one row per canton. There we go. Now we can cross-join the yearly summary data that we already created beforehand. So this has the sums of all the years. So when we put in this YSU table, yeah, they're aggregate functions. So we actually need to kind of find a way to do that. We'll just use max. Oh, it didn't like that. Because of all the records. Okay, let's take one. Oh, Gabriel Bioinfo, thank you very much for the follow. Much appreciated. If you're enjoying the stream, do let me know. So the sum of 1992 is the sum total of 1992. So you see here this 23272. So instead of just doing this in two separate ones per year, now we can implicitly do it in each one, and that does it like this. So we do YSU dot sum of 1992. You can get rid of this. Make this one a float, as we saw before. Need to have that decimal. What's happening here? Must appear in the group by clause. Yeah, this is because each of these values has already been aggregated, so we're just going to use a workaround with the max. And we can see here, Argyle has 6.6%. And if we remember before the percentages that we saw Bern had like 13, Vode had like something like 11, yeah, and Zurich had 13 as well. So this is basically what we wanted to achieve, and this is obviously a lot more work than just writing out this number. So this 23272, obviously we could just write this in here, right? And we get the same results. But the difference is that this has now been kind of automated, right? Because we've done this for every single row. So, copy paste time. We're going to do this for every year. And we're going to do something exciting with that, probably later, maybe. For the moment, I just want to look at some basic statistics about what's happening with the accidents per year, per canton, essentially. And so this is a sort of like incidents. I don't know how we would call this. Incidents isn't the right term. Maybe it's just a percentage in the end. It's just a percentage. So if you've joined recently, if you have questions, do feel free to ask in the chat. I do like interacting with the audience, which is why I am streaming on Twitch. So if you do want to know something in particular, just let me know. And this is, if you're just joining, this is a data set from the Federal Office of Statistics in Switzerland, FOS, hence the Shima name here, FOS, about road accidents in Switzerland. So that covers everything. It covers accidents of people on bicycles, covers people of accidents on scooters, really everything. 2015, 2016, 17, 18, 19. And again, I don't like doing this, but sometimes it is necessary to sort of manually type it out once. And as I showed you before, if you have that data, then you actually can copy and then move over, because everything is the same length, which is very convenient. You only have to do that once. There we go. So what do we have? We have, well, I should probably rename this. We have magic. You're right, we have magic. We have the percentage of each canton. So we're going to run this. So this is the percent contribution to accidents per year for each canton. And this is where it starts to get interesting. Now we can start to look at, okay, how does it change over time? You know, do some cantons have a stronger contribution to the accident rate? Let's look at Zurich, for example, the canton I live in. It's also a city, but the canton itself is Zurich. So it started out at 13.3%, 12.9, 13.3, and then in later years 14, 14, 14, 15, hovered around 15 here again, and then now closer. Oh, Christy knows, charts time. You can see that it is a bit difficult to read this. That's definitely the case. So one thing that we can do is we can actually just, well, we can chart this. How can we chart it? We could do a simple way of just exporting it and, I don't know, putting it somewhere. We could put it in Google Sheets, for example, just to be just an easy way. So we're just going to export this as comma-separated data. Unfortunately, you can't see this export window, which is unfortunate. But I will tell you that I'm exporting it as comma-separated data with semicolons. I've exported it to a file. So you can see here in the bottom right, this result 43. And then I'm going to probably just put it into a Google Sheet. Let's do that. So I need to add this as a source here, because I actually don't have it. Give me 1 second here. So G Sheet. Didn't do my preparation. Google Chrome. Untitled spreadsheet. There we go. So that should work. And I can just take it out there again. All right. So what are we going to do with this? We are going to basically try and figure out if this data looks weird. So let's import. And as Chrissy said, chart time, we can definitely do some cool charts in something like Metabase or something like that. But this is an easy way of doing it. So data, let's split the text to columns, semicolon. So that looks like it all imported correctly. I'm going to do the lazy version and just select the whole thing. Well, no, let's make it formatted first. Let's do the formatting first. So we're gonna do like that. And we can already see like which ones have higher percentages, but we can't really see how those percentages are changing over time. So let's do chart. Now Google should actually suggest, based on my experience with Google, what chart is right. Oh, look at that. So that's one way of doing it, is just doing the insert function. So we can see kind of some of them that changed a lot. I mean, it's not a great visualization, to be honest. Like, I can see Ticino really lowered their accident rate. But that's probably because it just started going up in other cantons, like Geneva started really increasing. You can just see from the sort of line of the tips. But I'm sure that we can actually figure out a better one. Something like this, stacking, would work. with the colors here, we can see if we did stacking and then maybe we should actually switch them around. There we go. So we have each canton is a different color with the exception of Zurich and Zug. So we ran out of colors here. That's not so great. So we can see kind of where the contributions are. Then we shouldn't actually stack them 100%. We should just do no stacking. Yeah, it's quite difficult to read as well. There's probably a lot of different visuals here that we could be using. It's quite difficult to do that. We could also do probably areas where they do overlap a lot, but we could do some stacking. So here, for example, this is actually not bad. If we did have better color choices, we could probably, or if we just reduced it to 5 or 6 that we wanted to look at. So that would be one thing here is, for example, if I only want to look at, let's take, maybe we can just sort these. So we'll just make a filter and we're just gonna take, I don't know, let's sort them by value. And then we're just gonna take sort of the top 10 or something. And everything else we're just gonna ignore, for example. Or let's take the top 5 because those are significant. And we'll just take out the other ones. I'm just gonna delete it. It's not the right way to do it, but yeah. This is easily, now you can really see the patterns. You can see, for example, Aargau hovering, right? And you can see others like Zurich increasing over time. Now, yeah, some cantons, Christy, you're right? Difficult but beautiful, definitely. I mean, there's way more you could do with data visualization. I haven't gone into that to some extent yet in the streams, but I would like to do more of that as well. Some cantons got decreasing accidents. At least their number of accidents, not necessarily in terms of raw numbers, but in terms of their percentage contribution to the total number of accidents in Switzerland for that year, yes. Is that because other cantons were increasing? I mean, there's a lot of different variants in that data that we don't know about. So that's something we'd have to look at in more detail some other time, I think. Yeah, what can we do now with this data? Well, we could technically start joining other stuff onto this canton. So we'd have to figure out what other data do we have based on canton that we could use to just add to this data set. And for simplicity, I'm going to just only take the last 5 years. And I'm just going to comment out the other years because I don't need to see them for now. We could always include them later, but it just makes it a bit easier to work with. So we're just working with 5 years worth of data. And I mean, the last 5 years is already, it's significant enough. It's going to tell us something, right? So we have some other data in here like this, location type and stuff like that. And I'll come back to that in a second. But I think it should be interesting to sort of figure out what about other stuff about those cantons. So one thing that interested me, and I think this was, no, it's not in this table. So persons, we don't have the people, we don't have the canton in there. We had the road conditions. We can definitely look at that in a second too. But we had, that's right, in the street index, we had basically the canton. And so one thing I was wondering is like, how many streets are there in each canton? And is as a contribution factor to the accident rate, is there a contribution to it? I mean, it's possible, but we don't know. It could be that the more roads a canton has, the higher the accident rate. I don't know if that's the case. But we can try and figure that out. And one way of doing that is just getting some counts of this table, of this data set. And so we can add that to our existing query. So let me just fold that in. What are we going to call this? We're going to call it street counts or street aggregates as. Oh, you see here, I didn't do it again. It's such a bad habit that I don't write this alias in here. You see here, like it's missing for all of these. Oh, now I got to change it. Huh? It's just one of those things. It just irks me afterwards that I didn't do it. While I'm doing it, it doesn't bother me. But later, when I look at it and I realize it's not there, it irks me. Sorry. So 2014. This is a great song. Let me know if the music is too quiet, by the way. Not sure. I tested the volume beforehand just to see if it was okay. So, street aggregates. How are we going to get the aggregates? Well, we are going to just do select from Swiss topo.streetIndex. We're going to call this str. Christy, so may I ask you, where did you learn PostgreSQL? Nice skills. Have you used Udemy courses or something like that? So thank you for the compliment. Thank you so much. I'm self-taught. I did learn a lot of it at my last job, where I was heavily involved in writing a lot of queries, especially in the last sort of 7 to 8 months of my work. But I'm self-taught. I don't have a formal education in database administration, and so I just taught myself. I didn't use any online courses per se. I didn't like subscribe to Udemy or Coursera or something like that. I basically understood the basics very quickly and then taught myself the rest by lots of Stack Overflow and Googling and things like that. Some people, they learn in different ways. Personally, I learn through practice. Like I need a lot of practice. I would say like 80% practice and 20% theory to fully grasp something and understand its concept. Much like the sort of geospatial stuff with lat/lon and things like that. Like I can read as much as I want, but until I actually put the data into a table and start playing with it, I'm not really going to understand how it works and like the intricacies of it. Hope that answers your question, Christy. Are you looking to learn more Postgres or SQL in general? So let's continue with these aggregates. So I want to figure out how many roads are there in each canton. So we can obviously take the canton first, so this com canton. And it is generally best practice to use the alias, even if you're only using one table. I think it is best practice to do that. Generally speaking, I think it ends up being a bit cleaner. So we're going to call this just canton. And now we want to count something. What do we want to count? Maybe we want to count this street ID, because this STRESID is actually unique, as far as I know, but there's a way to check for that. The one way to check that, so nice, thanks, impressive for self-learning. I have this task in my stack to level up my database knowledge. Wonderful. I'm hoping that you can learn something from what I show here. If you have questions, feel free to reach out as well. You can contact me on Twitch. I also have my LinkedIn. You can write me a message there in my About. I also have a link to my website. You can actually schedule coaching for 30 minutes. If you do have some specific things you'd like to look at, I offer that free of charge. Will I save my streams on YouTube? Oh, this is a very good question. I've read a lot about recycling content for YouTube. For the moment, I hadn't thought about doing it yet. I have the videos. I might publish them. I might edit them, trim them a little bit, take out all the useless figuring out parts and just put in the useful stuff. But it's a time investment that I would have to make. So I'm not so sure. Yeah, but I've read that recycling the content for a YouTube channel might make it easier to find, and then more people might maybe land on Twitch. So that's also something to consider, of course. Yeah, I do stream for myself. Like, I'm not streaming for everyone here. I'm glad, of course, that people join, and I'm glad if we have a conversation. But I'm finding this stuff out because I'm curious about it. Like, this is the idea that I had at some point, and I wrote it down, and then I thought, okay, this is something I'm going to tackle in this stream. I spent some time before. I'll probably spend some time after as well investigating it. I may do another stream on it because there's a lot of data here, and we're already sort of an hour 45 into this one, and I don't want to go too far past the 2-hour mark. So, yeah, there's enough material for sure. But I need to think about it, Christy. Yeah. Just another hydration here. So one way to figure out if this str ESID is good or not is to basically do one thing, and that is the following. First, I run a simple count of the rows in the table, row count, and I also run a count distinct of this field. And by doing that, I get 2 values. If those values are the same, this field is unique to this table. Very, very simple. So I know that this field is unique. I can now use it in that way. So I have the canton and the street count per canton. Now, because I'm doing a aggregate with a dimension, I need to, of course, add my group by. And now I have every canton, 26 values. It's also very easy to remember how many we need to have. We have the number of roads per canton, or street count. Now, there's something we saw before. Christy, you asked this question about the different street types. By the way, are there other street types rather than street? I think it was. And this is kind of interesting because this is not the street count yet. This is the street count of all the records in this table. But we know that there's different types. So we need to add this where condition. So we're going to say where str type equals street. And now we have the real street count. And you can see how much it changes things. So for example, Aargau is at the moment 14,700. And you see it bumps it by about 2,000. So we definitely need this filter in here. It's very, very good practice to just filter data for what you need. So I can see there's a couple other people in chat. I'm not sure if they're actively watching the stream or not. Do let me know if you have questions or comments. I'd love to know what you think about the stream today. I'm trying to improve my streams, of course. If I am showing something that I'm working on like today, of course I'm working on it for myself, but I want it to be understandable and entertaining as well for others. So yeah, do tell me if you also have suggestions for how to improve things. So we have this street aggregates table. What do we do with this now? Well, I think that's an easy one to answer. We are going to, oh man, I don't know what to do with these. They're in my way. I'm going to get rid of them, sorry. I'll add them later if I feel like adding them later. We're going to add it to our sort of overall aggregate that we have. So we have street aggregates. I'll just close that here. And at any time I can also run the query like this by just highlighting this line. So I already noticed something a bit odd about this table, and that's that Fribourg only has 3 streets. I don't think that's true because Fribourg is a relatively large canton. For whatever reason, the streets are not assigned to this canton. It may be that the streets start somewhere else and then they're assigned to another canton. This is a bit weird. Definitely have to research that data set a little bit more. I didn't do so many quality checks yet, but that's definitely a little bit concerning. Because other cantons, like Fribourg is relatively large, it should have like at least 5,000 or 6,000 roads. So that's a bit strange, but it's something I'd have to investigate. So we have a cross join in here. So why is such a huge number of streets in Aargau? It's a very large canton as well. So Bern, Aargau, Zurich, Geneva, they're quite big. St. Gallen is also very large. In terms of surface area, you can see that there's a lot of roads in these individual cantons. But this is what I'm interested in. Okay, maybe we'd have to discard Fribourg because it's not correct. Or for whatever reason, this data set is maybe incomplete. But we can now join, and this is actually just a classic left join. If we did an inner join, it would only take values that are in the table, and I just want to avoid that. This is kind of like my master, this one, right? This is the road accidents. So I can left join my street aggregates. Let's call them SAG. And we can use the canton field here because we have the canton value here, right? So if we just run this without, we can see this, right? And if we just run the street aggregates, you can see we have the canton, but you may have noticed that there's something different, and that is that this canton value that we have in our road accidents data set is not the real canton. I mean, it's the real name and not the alias. And so I actually wrote already a case when earlier today because this was a real pain, so that we can actually join these two together. Otherwise we would not be able to do that. So instead of having, so we're going to call this canton name, and then we're going to have a case when here called canton code. And the issue with this is that I cannot join this onto that because the canton code is only being created in this query. So what I need to do is actually make this another common table expression. So I need to add a comma here, and then I will call this as, I don't know, canton rollup as, I do like using the rollup term. Take that out for now. Street count is number of streets and not oh yeah, no, it's correct. The street index is the number of streets itself. It's not the number of accidents on those streets, it's the number of streets per canton. And that's why this Fribourg value is definitely not correct, but I'm not sure why. So that's something to investigate. We can maybe just discard Fribourg from the analysis for now. We can just look at sort of the big ones like Aargau, Zurich, Bern, for example. So yeah, we have this canton rollup, and that's my last query. So I can take this canton rollup, and if I do select star from that, then you see here I have the canton name and the code in here. So I can do now the left join that I wanted to do, which is the street aggregates. On the street aggregates canton is actually, it's not rack anymore, cro.canton code. And now you'll see canton and the street count. So I now have everything in one data frame. Now I obviously only need to include the canton code once, so I'm just going to include the canton code. I'm going to include the years, 2016, 2017. Sorry, I just need to sneeze here. So 14th, I can't imagine 14,000 streets. Yeah, me neither. I mean, there are that many, for sure. I mean, I've driven through a lot of them, but it's very hard to imagine that many streets. So we have the canton code, and we have the accident values, and then we have the street count. Oh, that's the whole table. Street count. Let's see what this looks like. So we now have the kind of incident, well, we have the percentage and we have the street count. Now, we have the same problem as before, as earlier. Do you remember that we had the same issue, which was, okay, I want to have the sum, or let's say the street count, also in a percentage, so that we have each sum of the streets, not only by canton first, and then afterwards we can work out kind of what's the percentage of each one. So we can actually rename this to street aggregates canton, or rather, let's call this street aggregates first. And what we can do is we can do the same thing that we did before with the yearly summary. Basically, we just make a sum. Instead of using the canton, we just count distinct the street count. This is our total. And obviously, this is a bit easier because we only have one value, which is this number here. I don't know why that got small. 15, 45, 20. 15, 45, 20. So we have a total of 154,000 streets. Seems like a lot as well, but it's definitely possible. Switzerland's a very densely packed small country, so it's definitely possible. And so this is my street aggregate. Now I have like a fixed number. So if I wanted to figure out the canton's individual contribution towards this count, then what I would do is do the easy way, which is canton. Let's call this canton code. And what I'm going to do is, instead of dividing it, so instead of just doing the count here, I'm going to do directly this street count for each canton divided by this number. Because I don't have several years worth of data, I can do it this way. So what we did before with the different years, we couldn't do that with one fixed number. Here we just have one fixed number, so we can easily do it this way. And then I need my group by again. What I end up with now is not only a count, but actually a street percentage per canton. Let's just run that again. So this is my percentage. And now we can actually use this street per CN, change that, canton code. And now when we have this data set joined together, we also have this number. Granted, the street counts might have changed over the last 5 years. It's unlikely that they change significantly, like that somehow there were 1,000 new roads where there weren't before. They obviously do a lot of road work, but it's mostly repairing roads. So I think it's definitely okay to use this value as like a fixed value for the last 5 years. And so again, we're going to export this data set. You don't see the export window, but now you see that it's been exported here. Result 59. So we've done 60 queries today. That's incredible. It's actually really awesome. And we're going to do another Google Sheet tab. Let me just bring that up for you again. Blinding because they don't have dark mode. So let's upload that result 59. Ekaterina, nice to see you. Thank you for joining. How was your stream? Did it go well? I'm used to the huge distances in Moscow and Russia. We have long streets. That's why I was confused. Yeah. That makes sense. So we're gonna just replace this. And you see, Ekaterina, I have music playing this time. Isn't that nice? It's definitely not copyright free, I can tell you that. But my channel's not monetized, so I'm not too concerned right now. Feels good. It does feel good. So, are there correlations? This is the question. Are there correlations between the percentage of street number, or the percent, that's not the right way to say it, the amount of streets there are in Switzerland in each canton, and the accident rate? We can already see there's probably something to it, but there's also some weird ones. Let's chart this and see what Google thinks we should do in terms of chart types. You guys are speaking Russian in my chat. Now I totally don't understand what's going on. So, this is what Google suggested. Not great. Oh, you don't need to apologize, Christy. It's no problem. You guys can say whatever you like in the chat. As long as it's not vulgarity. Too much vulgarity is not good. I think we should customize this. I think that we should rather go for a combo chart. So we're going to do a standard stacked chart. I gotta configure this a bit more. So I want all of them to be on the left axis. And then I want the street per CN. Oh, I can't change these individually. Alright, column. Ah, here we go. So everything is a column on the left axis, and then I'm going to change my street to area on the right axis. That's weird. Why doesn't that work? Oh, because it's stacked. So let's do line instead. Okay, that works. To make that thicker. And probably a weird color that stands out. There we go. Should we still stack? There we go. So what do we think about this? What do we think here? So does the correlation have something for us? I would say definitely. Like so the spike, what are we seeing here? Basically the spikes are where there is a high percentage of roads in that canton of a total of all the roads in Switzerland. So that's quite interesting that, for example, St. Gallen has a very high percentage of roads, almost 15%. Katerina is disappointed how C# is going. I told her to take an example of you. Oh, that's very sweet. I appreciate that. A lot. A little bit lost for words. Thank you. I appreciate that. liked Ekaterina's stream when she was streaming SQL. Now I don't understand anything anymore. Because it's a different programming language. Oops, I just broke something. So, what do we see here? It is interesting. I mean, I would have expected a high number of roads to also cause more accidents, but we see that there's some inverse cases, like in St. Gallen, for example, where there's a very high proportion of roads, but the accident rate is not so significant, whereas places like Bern, the accident rate is in-proportional to some extent. Aargau sort of follows the pattern. I mean, there's no definitive answer in this case, but there's definitely, I wouldn't say it's a very strong correlation. We could do, of course, a standard correlation of the two series together and stuff like that, but I just charted it for visual purposes. So that's the excursion. What's there to be said more about this? So remember in the beginning we talked about how we can roll up everything onto Canton? Well, it's not entirely true, because that's basically all the data that we have on Canton level. So we have this table here with the Canton in it, but these other tables, for example, the causes. Christy says, nice stats, so clearly. Thank you. I don't know if we really found out something yet, but there's definitely something behind the number of roads and the amount of accidents that happen. So let's see if we can figure out more about the roads. However, we can't figure out more about those roads on a cantonal level. It's not possible, because we don't have the canton as a dimension in these other tables. You can see here we have everything else, but we don't have the canton. So, one thing that interested me, and this is, I would say, a very personal interest. I ride a motorcycle, and I've been told many, many times over the years that riding a motorcycle is very dangerous. More dangerous than anything else. But is that really true? At least in Switzerland. That's the real question. And so it's something I'm going to start. I don't know if we're going to finish it today, but it's something I'm going to start with basically this roads table. Because I have like this table about the conditions of the road and where the road is and all this kind of stuff. And I also have in this causes table, where was this? This object. So I have technically the ability to join on this type of road. So here I have Autobahn, which is highway. And in the roads, I also have Straßenart, Autobahn. Now this is dangerous, of course, because this data set doesn't have the vehicle type in it. But logically, if I make the sum of all the Autobahn accidents in 1992, I should have the same number of the Autobahn accidents here in 1992. With the same, like, with all the criteria excluded. So Chrissy says, oh, it's a nice task, I'm interested too, real bikes versus car safety. Well, yeah, I mean, it's not necessarily a myth, or it's like a myth that we want to test, whether a motorcycle is more dangerous than a car. Of course, this only accounts for the number of accidents, it doesn't account for other factors, like your loved ones being worried about you or something like that. But I think it's an interesting idea. I don't know how far we're going to get. So what I'm going to do is I'm going to close these other tables. The work that we've done here is not for nothing. Here. The work that we've done here is definitely not for nothing. I'm going to save this, but we're going to start kind of fresh for these tables. And so we have to start fresh, and in order to start fresh, we have to pick where we're going to start from. Personally, I think I'm going to start with the roads table and then join the causes table to it. But that's just personal preference here. So let's do this very straightforward first. FOS dot road accidents roads. This is the RAR table. Sorry, I like to make sounds sometimes when I make abbreviations of my tables. I don't know if you guys do that as well. That would be funny if you did. So we're gonna take this table. This is the road accidents table. And so I have this Straßenart. Straßenart is, I would say, road type. I'm gonna rename all the fields, don't worry, so that we can do it together. But we're gonna do a common table expression for this because I just want to save it in a data frame first. So data frame just means I want to be able to work with it outside of the select. So data frame as select blah 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 rar, and we're going to just do a join here, which is basically a full join. You don't need to write full join, you can just write join, unless you want to do inner join or outer join, then you should write. By the way, do you use materialized views to present final data representation? I'm not sure what you mean by that, Christy. What do you mean by materialized? Be interested to know what your question is. I'm curious what that means. I've never heard that term before, so maybe it's just me not knowing what that is. And we also want to join now the causes table, road accident causes. It's also rack, like before with Canton, but yeah, we're not using the Canton here. And the rack.straßenart is the rar.straßenart. Now we have to be a bit careful. Let's see if we can actually count, if we get the same counts for these two. So rar star, we just use, let's just take everything for now. Select star from data frame. Sharpclaw, good night to you. Thank you for joining the stream. Oh, it's a view that contains your query results. It could be cached and quickly accessed, but you got to invalidate cache yourself. So this would be like a view instead of a table. I don't do so much in database admin, but we could obviously make a view of our final result here. So for example, this table that we have with these 26 rows, we definitely could have, we could make a view of that. We could also just make it another table. I think at 26 rows, it's not a huge problem. But yeah, if we're doing a lot of like common table expressions, it would definitely make sense to have a sort of cached version of the aggregates in another table or in another view. Which you would select would be more of a question for like a database admin, which I'm not. Yeah, I'm very much focused on sort of the intersection of business and technology. So I have a tech side and I have a business side, but how do I store the final results of my investigations? Kind of depends. I make a lot of notes. So when I'm showing stuff on Twitch, I'm not making so many notes, but typically for my work, I would be making notes next to this. Like the Google Sheet that we saw, storing sort of like intermittent findings. For example, at work, we use Confluence, which is a Atlassian product, to kind of like a wiki. And there I would actually document as I go with the findings that I find, attaching like charts or screenshots and things like that. But I would actually prefer to use something like Markdown, but I haven't looked into it yet so much. A colleague of mine at work uses Markdown like a notebook to annotate and do charts and things like that. And he's like a data visuals expert, so I would definitely like to take a page out of his book, as it were. So I've selected everything from this data frame. And what did I get now? Query that took longer than 5 seconds, which is also exciting. Well, this is taking some time. I'll have a drink while we're waiting. Well, that's a huge query if it's taking that long. Guess it's multi-dimensional, right? That's pretty crazy. That's taking a long time, which I don't appreciate. So we're going to do the short version. Hello. Thank you. So I've stopped the query from running, probably because my machine is getting tired. I can see the usage peaking here of the memory. Yeah, I mean with streaming and everything running at the same time. So we will just do some aggregates directly. So we will do rar.straßenart. Then we will do rack.straßenart. These should be the same. Distinct. This could take a while. Oh, there we go. So that's good. We have the same road types in each of these data sets. That is very good. We don't need to do any manipulations. Now we need to start doing the sums. So rar.1992. So we need to sum this. This is the sum of 1992. Now we need to definitely name this somehow smartly. Again, forgetting the alias. Road type. What should we call this? I can only translate Autobahn. Yeah. There's actually a very small difference between Autobahn and Autostraße, which is kind of funny. But yeah, Autostraße is like almost the same as a highway. It's like a fast road, basically, which in my eyes, Germany is basically all fast road, but they all call it Autobahn in Germany as well. We need to call this the sum of 1992, and this is the roads. We're just going to call this RD. And then we're going to do the sum of our rack.1992 as sum of the causes 1992. And I hope these are the same. Oh yeah. See, I forget the group by every time. It's just one of those things that will happen. Every time I stream, or whenever I'm doing SQL, I will always forget group bys. Oh, okay. So we have a problem here. So the issue that we have is we have a lot of accidents, by the way. Like, this seems like a very, very high number. I don't really believe that that's real. Oh, you are not alone. In what context, Christy? That you forget the group by? Oh, yeah. I'm so glad that someone else forgets it all the time. So I don't think this number is realistic. I think there's something fishy going on here. That's a bit weird. That's definitely a bit weird. Maybe we just do 1. Or we left join it. That could also possibly... Could be something with the join. It could also just be the sum of these fields, which are being... That's odd. It's very odd. So I'll show you a cool thing with data grip. If I click this field, and I press this scroll from editor on the top left here. Where is that? Doesn't like this? That's weird. I can basically click on the top left here, this scroll from editor, and I can open up the direct place in the table where it is. So the causes table, it's odd that the sum is different. The sum of the, oh, I see. I see. So this is actually, it's a different data frame. That's the mistake. So the causes table has this possible cause, the object, the type of road, where it happened, and deaths heavily. What is Unfallschwere? This is the severity of the accident, exactly. So deaths, heavily injured, lightly injured, deaths, heavily injured, lightly injured. And actually this is not good because we have duplicate counts in this field, in this table. The reason we have duplicate counts is because this data cube or this data frame is looking at the condition of the reason for the accident, but it's drilled down with the object involved. And of course, if you have the object in here, you also have others like, yeah, motorcycle, then they will also be, if there was an accident between a motorcycle and a pedestrian, so here for example, there will be a 1 in the pedestrian as well as a 1 over down here in the motorcycle, you see. So that is why the counts are different, because this one, the roads table, so this, sorry, jumping a lot here. This roads table, so this first one, the sum RD, is just counting the different speeds and the different conditions, and it could be that there are duplicates. One way to know would be to go back to our query with the yearly summary. This is how many accidents we had per year in total. Because remember, this is the data from road accidents by canton, but we just rolled them up completely. So we should have, for example, if we, oh man, that's not good. Let me just copy the last 5 years instead. So 2019, 2015. So we should have something like these numbers, right? And I mean, okay, the accidents increased for 1992. Let's do 2019 instead. Just to be on the safe side, we can use 2019. And if we run this again, so the sum of the accidents, yeah, this is way off. This is definitely not correct. Because the sum of the accidents is for the whole year 17,000, and we've already got 741,000 accidents in other road types, which is definitely not possible. So what do? We start debugging. Debugging means taking stuff out and figuring out what's happening. Easiest way, just start adding the dimensions back in. So we have in our table, so this is the location. Debugger time, my favorite. Wouldn't say it's my favorite thing, but yeah. So now we start adding stuff. So this is interesting. Adding the location in here seems to provide better numbers. If I were to sum this, let's sum this. Let me bring this G sheet in here. So I typically just run, for example, this just to see. So 17,761. And if we look back at our data group here, 17,761. So this is correct, this sum for 2019. So debugging is short today. What happens when I take out location and just group by 1? So this is correct. All right. So that's interesting. Can I not left join? That seems odd. Ah, I know what's happening. It's creating additional rows from the left join. So we need to create our data frames separately. That's fine. We just have to have the stuff separate. Not an issue. So basically we just have road type and 2019. We could do the other ones afterwards. We'll just copy paste it. Group by 1. This is our roads. Then we have a second one, second common table expression. This is going to be called causes. As select distinct star from FOSS. Road accident causes. It already knows what I want. That's pretty nice. Pretty nice indeed. So rack.straßenart as road type. Sum of rack 1990. Oh, sorry. Stuck in 1992 here. 2019 as sum causes CS 2019. So when I run this, oh man, look at that, forgetting the group by. It's awful. I really should have like a pop-up or something. Or should become like a meme. Don't forget the group by. So we have the group by here, and we have the group by roads here. This is wonderful. We get a different value, which is interesting. I wonder which one is correct. So the roads one, just to look at this data set again. So this is blown up by category of the Unfallschwere. So it's like the severity of the accident. So these are like accidents with deaths. And so I guess an accident can only be classified once. Christy, you have to go. Nice stream. Thanks for the deep dive into the topic. Was very interesting. See you. Thank you for joining and for your questions. It's made it very interesting for me as well. Hope to see you next time. I hopefully will stream next week. I'm not sure exactly when yet. New year, new stream. Hope you have a good new year. So yeah, we see that this table is broken up into accidents categorized if they had heavy injuries or not. So it's, I mean, it is possible that an accident has been categorized in two categories, because if it had heavy injuries, yeah, that's interesting. So that's the roads one. Which was the one that we counted? The roads one. So the roads one is definitely more correct, because basically the roads one, yeah, the roads one is only categorizing the accident once. And I think the causes one, because different people can be involved in the same accident, That's why the causes one is higher. And the way that we can add these together is basically select star from roads. I don't know, RDS. Just realized I never make an as alias for my tables. That's also terrible. You guys should be telling me about that, because I don't think it's very good. So, and then we'll just join on our causes table here. Cause as cause. Cas? Call? Cow. Cow.road type is the RDS road type. And of course, once we have this whole thing, you can see that these are higher. So the number of accidents here is being higher counted. And that's not correct. So basically, we're gonna fictitiously work out if we can actually use this data in some way. So let's see, you have the possible cause of the accident. If it's not possible to do this because the number of accidents are being double counted in this table, then we'll just have to analyze this table on its own first, which is also fine. But we definitely learned that already based on this query that we cannot use these two tables together, which is unfortunate. I mean, I would like to have one data cube. If they could provide me that, that would be fantastic to have like the whole data cube of everything in one go. But it's not possible. And seeing as we are nearing the sort of 2.5 hour mark, I think I'm going to call it a night for today. But I will pick up from this point next time in next stream. I don't know when that's going to be exactly. Probably next Monday or Tuesday. I have to see what schedule I want to follow in the new year. As I did just start streaming, do let me know what time is convenient for you. Would be great to know. Obviously, I'm on European time zone, so I can sort of swing earlier in the day or later in the day. Granted, later in the day is usually easier because of work commitments. So I work a sort of regular 9 to 5, relatively regular schedule. So it does make sense for me to do something in the evening, but I'm also open to doing something in the morning. That's also fine. So I'm going to leave that here for today. If you do have suggestions for the stream or anything you'd like to know, send me a message here on Twitch or on LinkedIn or on my website. You can also access my website, matty2shoes.com. It was nice having you, and hope you enjoy the rest of the year and that you start 2021 off in a good way. Thanks a lot, and see you next time.